Hello everyone, I'm Benjamin Contreras, and welcome back to the second part of my learning about Newton series. Now, in the first part, I talked about Newton's four main laws of motion, and for part two, I'll be talking about a series of questions that people have been asking that I found the most interesting about Isaac Newton. So, question number one is, how does the law of inertia apply to the motion of an object? Now, for this, we'll say that if you take a car, like a toy car, and there is a block on top of the car, you just place it on top. There's nothing attached. There's nothing attaching the block to the car. It's just sitting on top of there. So, if the car goes and hits a unbalanced force, like say that there is a wooden block in the way, if when the car hits it, the car will stop, but since there's nothing connecting the block to the car, the block will still be moving as if the block wasn't there. So, as long as there's nothing being attaching the block from the car, the block will still move even when the car stops, because the they're both two different forces. They're two different objects that aren't connected in any sort of way. Now, question number two is, how can inferences be drawn from observations of motion? Now, this is basically, say that when you're observing someone who is moving. Well, actually, I should probably say this first. What you have to do is find a reference point. Now, what a reference point is that it's an object that is completely still. It doesn't move no matter what. So, say that you're in a class and it's a science room and there are a whole bunch of tables that are attached to the floor. Now, say that someone is behind the table. Both of them are not moving at all. But when you take when the person moves from the table, when you're observing him, he moves like right here. And then let's say he'll move to here in a few seconds. Then he'll move back to the table. You know that it's the person who is moving because the reference point is the table. Since you're observing him when he's near the table, when he's moving, the table doesn't move at all. So you know he's the one that's moving because the table is the reference point. So, number three is sort of a bit complicated because I already sort of answered this question in my first part, because the question, first of all, is how is force, mass, and acceleration related? Now, the reason why I did this in my first part is because basically Newton's entire second law, the meaning of the second law, pretty much answers this question. But since this is the new part, I might as well say it again. Newton's second law of motion states an object's acceleration is in the same direction as the net force of an object and is equal to the net force exerted on it divided by its mass. So, basically, if you know its second law, then you will know the answer to the question. Now, number four is, why are forces always in pairs? Because the reason why is because forces always interact with each other, no matter what. For example, I'm holding this. We are two different objects. I'm interacting with the marker by holding it, but the marker is also interacting with me. So, like I said, there are also several different ways you can do this. Like, say that you put like, let's say that you put this on top of the board. The board and the marker are interacting with each other because one is standing on top of the other. So basically, if you're simply doing something like you're sitting down, if you're sitting down, both the objects interacting is the chair and you, like the stuff like that. Now